All right, so we're going to go ahead and code this. I'm going to leave a lot of it up to you this time, but I am going to go ahead and show you a few things. So I'm starting from where we started before, and we have some sort of launch, right? And we want this to be a little more realistic. So let's go ahead and set it up similar to the parameters that we had before. Okay, so this should be kind of similar to what we had before, and so we've got a launch and we've got a landing point somewhere. And our goal is to go ahead and input this other model that we've derived here. So we have this other model. We have the equation here. We want to go ahead and get a value for B. There's a couple of ways we could do that. One would be some experimental data where we fire just straight upward, or where we drop the arrow, the ballistic dart is what we're calling it. It's a Nerf dart. And you drop it from some distance, and you just see how long it takes to hit the ground. You see, then you'd have y equal to 0. You'd have your initial velocity as 0. And so you could actually solve for B. And so there's a way to do this. I'm going to provide you with a value here. And so you'll go ahead and code that in. One thing that you might do to see the ground a little bit more effectively is go ahead and just set up, okay, so we have this x vector that we already made. And what we might go ahead and do is set up a y vector that's just a bunch of zeros. So it's going to be zeros, and it's going to be the length of x, right? It's going to be as many zeros as you have x's. And that's going to be in a black line. And what that'll do for me is it'll provide me a little bit more of a ground. And that way, as you add your ballistic in, you can see the ground, and you'll be able to see your air friction. Okay? And so go ahead and try to do this. I've named mine xlin and ylin. That might be the way to do it. And also be careful of the character B. We already had a B in our code. So I named mine B and then F for the function, right? So it's the B that's from the function. Okay, so good luck, and it's interesting to play with. You'll see the linear air friction breaks as you mess around with too many values of theta.